Section 5.2, Binomial Probability Distributions. A binomial probability distribution results from a procedure that meets these four requirements. First, the procedure has a fixed number of trials. Second, the trials must be independent. Third, each trial must have all outcomes classified into exactly two categories. Third, each trial must have all outcomes classified into exactly two categories, commonly referred as success and failure. Four, the probability of success remains the same in all trials. Notation for binomial probability distributions. S and F stands for success and failure. Denote two possible categories of all outcomes. P of S stands for probability of success, which is P. P of F stands for probability of failure, can also be called Q, equals to 1 minus P. N is the fixed number of trials. X, a specific number of successes in N trials. So X can be any whole number between 0 and N, inclusive. P, probability of success in one of the N trials. Q, probability of the failure in one of the N trials. P of X, probability of getting exactly X successes among N trials. Example 1. When an adult is randomly selected with replacement, there is a 0.85 probability that this person knows what Twitter is. Suppose that we want to find the probability that exactly 3 of 5 randomly selected adults know what Twitter is. Question A. Does this procedure result in a binomial distribution? In order to answer this question, we are going to check to see if this procedure satisfies all of the four requirements. First, we want to know if the number of trials is fixed. So here they say, suppose that we want to find the probability that exactly 3 of 5 randomly selected adults. That means they are selecting 5 adults. My N is 5 and this number is fixed. The second requirement is that each trial is independent. We are selecting 5 randomly people with replacement. That means each one of those is independent. The third requirement is that each trial has 2 different categories. When I select 5 different people, I will ask them if they know what Twitter is. And the answer is either yes, they know what Twitter is, or no, they don't know what Twitter is. And the fourth requirement is that each trial will have the same probability. For every adult that I'm selecting, there's a probability of 0.85 that the person knows what Twitter is. This procedure satisfies all of these 4 requirements. So yes, this is a binomial distribution. Question B. If this procedure does result in a binomial distribution, identify the values of N, X, P, and Q. N is 5. P is the probability of success, which is 0.85. Q is the complement of P, which is 1 minus 0.85, which is 0.15. X is 3. Example 2. Given that there is a 0.85 probability that a randomly selected adult knows what Twitter is, find the probability that when 5 adults are randomly selected, exactly 3 of them know what Twitter is. From here, I know N is 5, X is 3, and P is 0.85. I am going to use StatCrunch to find the probability. I want to find probability that x equals 3 because I want to know the probability that exactly 3 of them know what Twitter is. If you are working on a homework problem and you want to open up your StatCrunch, you can click on Question Help and choose StatCrunch. From here, click on Stat, Calculators, and Binomial. N is 5. P is 0.85. And I want x equals to 3. Compute. This is my probability. And I get 0.13817813. If there is instruction telling you how many decimal places to round, please follow the instruction. Since this one doesn't have any instructions, I'm going to round to 3 significant figures. Example 3. We previously noted that in between 1974 and 2011, there were 460 NFL football games decided in overtime, and 252 of them were won by the team that won the overtime coin toss. Is the result of 252 wins in the 460 games equivalent to the random chance? Or 252 wins significantly high? We can answer the question by finding the probability of 252 wins or more in 460 games, assuming that wins and losses are equally likely. From this problem, I have n equals 460. Here they say assuming that wins and losses are equally likely means that there are 50-50 chances. That means my P is 0.5 and my Q is also 0.5. And I want to find the probability that the number of wins is 252 or more. So basically, I'm looking for the probability of x is greater than or equal to 252. I'm going to use StatCrunch to find this probability. From StatCrunch, click on Stat, Calculators, Binomial. In this problem, n is 460, p is 0.5. I want x to be greater than or equal to 252. Compute. This is my probability. And I get 0.0224284. There were no instruction here, so I'm going to round it to 3 significant figures. 0.0224. And I want to answer the question if 252 is significantly high. Probability of x is greater than or equal to 252 is 0.02, which is less than 0.05. So yes, 252 is significantly high. Example 4. Based on a Harris poll, 60% of adults believe in devil. Assuming that we randomly select 15 adults, find the following. From the given information here, I know my n is 15 and my p is 0.6. Question A. Find a probability that exactly 4 of the 15 adults believe in devil. Exactly 4 means I want to find the probability that x equals 4. I am going to use StatCrunch for this. Stat, Calculators, Binomial. On this problem, n is 15, p is 0.6. I want x equals 4. My probability is 0.00741989. I got 0.00714,989. There was no instruction on how to round this number, so I'm gonna round to 3 significant figures. And I got 0.00742. Question B. Find the probability that the number of adults who believe in devil is at most 2. I want to find the probability when the number of adults who believe in devil is at most 2. At most 2 means x is less than or equal to 2. I'm looking for probability x is less than or equal to 2. I am going to use StatCrunch for this. For question B, my n is still 15, my p is still 0.6. I want to change to x is less than or equal to 2. My probability is 0.002789. And I got 0.002789. I round to 3 significant figures. Question C. Find the probability that the number of adults who believe in devil is more than 11. More than 11 means x is greater than 11. So I'm looking for p of x greater than 11. Again, we are still using StatCrunch. For question C, n is still 15, p is still 0.6. I want x to be greater than 11. And compute. My answer is 0.0905019. And I get 0.0905019. There was no instruction, so I'm going to round to 3 significant figures. And I got 0.0905. For a binomial distribution, mean is equal to n times p, variance equals to n times p times q, and standard deviation equals to square root of n times p times q. The range rule of thumb for significant values. Any value in between mu minus 2 sigma and mu plus 2 sigma are not significant. Any values that less than mu minus 2 sigma are significantly low. Any values that greater than mu plus 2 sigma are significantly high. Example 5. A previous example involved n equals 460. We get p equals 0.5 and q equals 0.5. Find the mean and standard deviation. For binomial distribution, mean equals n times p. My n is 460 and p is 0.5. So my mean is 230. Sigma equals square root of n times p times q, which is square root of 460 times 0.5 times 0.5, which is square root of 150, which is equals to 10.7238059. There was no instruction on how many digits they want me to round, so I will round standard deviation to 1 digit more than the original data. So the original data is a whole number. I'm going to round it to 1 decimal place. So my standard deviation is 10.7. B. Use the range rule of thumb to find the value separating the numbers of wins that are significantly low or significantly high. I have the mean in the middle, which is 230. And this number is the mean plus 2 times standard deviation. And this number is the mean minus 2 times standard deviation, which is I have 208.6 and 251.4. Everything between 208.6 and 251.4 are not significant. Any values that are higher than 251.4 are significantly high. Any value that are less than 208.6 are significantly low. C is the result of 252 overtime wins in 460 games significantly high. 252 is in here. It's greater than 251.4. So yes, it is significantly high.